we have integration of 1 over x square x minus 1 quantity square dx. We will write this fraction as a sum of simpler fractions, okay, called partial fractions in this way. So let the fraction 1 over x square repeated root x minus 1 square repeated equals x square, so we have to write x and x square. Since this is a linear factor, we will have just constant a, and in this case another constant b. Same thing here, x minus 1 and x minus 1 quantity square a, b, c, d, and we will determine a, b, c, d. Once we find a, b, c, d, then the integral becomes integration of first fraction plus integration of second fraction plus so on. Then the integral I is integration of a over x plus b over x square plus c over x minus 1 plus d over x minus 1 quantity square. We will determine the values of a, b, c, and d later. Okay, a is a constant, so we can pull outside and remains 1 over x dx. Okay, a outside and 1 over x, and entire derivative of 1 over x is natural log of x, absolute x, plus b outside 1 over x square. Okay, 1 over x square is same as, let me write over here, okay, 1 over x square is, when we pull to the top, it becomes x to the negative 2, and using the power rule, xn plus 1 divided by n plus 1, and which is negative in the front, negative 1 in the front, x raised to negative 1 is same as 1 over x, so negative 1 over x. Okay, so b outside times entire derivative of 1 over x square is negative 1 over x, plus c constant outside, entire derivative of 1 over x minus 1. So derivative of x minus 1 is 1, so entire derivative of 1 over x minus 1 is then natural log of x minus 1. Okay, because the derivative of x minus 1 is just 1, which is there, plus d outside 1 over x minus 1 is square. Take x minus 1 is square on the top, it becomes x minus 1 raised to negative 2. Okay, it's like this now, and when we integrate, we get the exact same thing, because the derivative of x minus 1, we are supposed to use u substitution, okay, and derivative of x minus 1 is just 1, so it behaves exactly like x square. So we get same thing times negative 1 over, instead of x we get x minus 1 plus a constant k. Okay, now let me simplify, and finally we do this algebra work and find the values of a, b, c, and d. Come back here, plug in, we get the final answer. In fact, the calculus part is over. All we have to do is algebra to figure out the values of a, b, c, and d. Okay, we could have found a, b, c, and d earlier. We solve this equation for a, b, and c, d. For first, we want to multiply both sides by throughout, or both sides by the common denominator, which will be always the bottom of the left, x square x minus 1 quantity square. Okay, x square x minus 1 quantity square. Then let me leave one space to finish the problem. Then from the top, multiply left side by this, we get this one and this cancel, so 1 equals a over x multiply with this x square 1x, x cancel, so a x minus 1 is squared plus b multiply second fraction by this common denominator, x square cancel, so b x minus 1 quantity square plus c, let's see, x minus 1 x minus 1 cancel, so x square and 1 x minus 1, x square x minus 1 plus d x minus 1 is square cancel, x square. Okay, now using from this equation we need to determine the values of a, b, c and d, and we will go back, plug those values in here, and we get the final answer. Okay, now we have only two factors, x and x minus 1. When we plug in x equals 0, we will get an equation. When we plug in x equals 1, we get another equation, but we might not be able to find all the values of all those values of constants a, b, c, d, because there are 4 unknowns. So what I'm gonna do is simplify the right hand side, okay, which is tedious, but that's the best option here. So ax multiply x minus 1 is square with itself, x square minus 2x plus 1 plus b, same thing, x square minus 2x plus 1 plus distribute cx cubed minus cx square plus dx square. We need to distribute more here, ax cubed minus 2ax square plus ax plus distribute b, bx square minus 2bx plus b plus cx cubed minus cx square plus dx square. Now we combine the like terms in the right side. Okay, so 1 equals cubic term here and cx cube, so ax cubed plus cx cubed, we can pull x cube out, so a plus c x cubed plus, how about squared, minus 2ax squared plus b minus cx squared minus c plus dx squared plus d, that many x squared. Now we go for x as ax, so ax minus 2bx minus 2b, that's it, that many x's. Then constant term is plus b. Okay, now we are saying this cubic polynomial in the right hand side is equal to 1. So 1 is same as 1 plus 0x plus 0x squared plus 0x cubed and so on. Okay, so when we equate the coefficients, when we are saying these two sides are equal, that must imply a plus c must be 0. Okay, the cubic x cube is 0x cube in the left side. In the same way, minus 2a plus b minus c plus d, okay, that this is the coefficient of x squared, and there is no x squared term, so 0x squared, that should be 0 as well. In the same way, a minus 2b, that's the coefficient of x, we don't have x term, so that means 0x, so that should be 0. And finally the constant b, we do have a constant 1, so this b must be equal to 1. Now we need to solve this system of linear equations. At least we already know b equals 1. Try to plug in b equals 1 so that you can find the other constant. From a minus 2b equals 0, we solve, so b equals 1, that's good. Now from the third equation, when we plug in b equals 1, we get the value of a minus 2 times 1, a minus 2 times 1 2, a minus 2 equals 0. That means our a equals 2. Now we have a and b. Okay, this is from the third. It involves all four. Let's go to the first one. A plus c equals 0. We just found a equals 2, so 2 plus c equals 0. From the first, 2 plus c equals 0, so c equals negative 2. Now we have all three, the remaining three knowns, a, b and c. Then use second and find the value of d. So negative 2a, negative 2 times 2, negative 4, plus b is 1, so plus 1, minus c, minus negative 2, so plus 2, plus d is unknown, equals 0. So negative 2, negative 4, plus 1 plus 2 plus 3, minus 4 plus 3 is negative 1, so negative 1 plus d equals 0. Move 1 over, or d equals 1. Okay, so a is 2, b is 1, c is negative 2, d is 1. So we go back and plug these values in, we get the final answer. So we have a natural log of x, a is pound 2, so 2 natural log of absolute x. In fact, this 2 can be put here, plus minus, minus, what is b by the way? B is 1. Okay, so b is 1, so minus 1 over x, plus c is negative 2. Okay, c was found negative 2, so negative 2 natural log of x minus 1. In fact, this 2 can be put on the top. And how about d? D was found to be 1, so this is 1, so negative positive, negative 1 over x minus 1. Okay, d was 1, right? D was 1, yeah, so no effect. Plus k, and this is the final answer. We can combine these two natural log terms, but don't have to. Okay, we could have combined this and this. It becomes natural log of x is squared, and this is minus natural log of x minus 1 is squared, and difference of two natural logs, that will be natural log of, in fact, if we combine these two, this will be natural log of, difference means it goes for quotient, x is squared over x minus 1 is squared. So okay, we could combine, but not necessary. This is it.